Hidden inside the world's largest dams lives a machine powerful enough to light entire cities. This is the Giant Hydroelectric Turbine, one of the most powerful machines ever built by humans.
Driven only by water, this giant hydroelectric turbine powers millions of homes every single day.
But how does moving water turn into electricity? The Giant Hydroelectric Turbine.
To understand the giant hydroelectric turbine, we must start from absolute zero.
Every hydroelectric turbine begins its life inside enormous precision engineering factories.
Each component is so large, humans look small beside it.
This giant hydroelectric turbine can weigh hundreds of tons. Built using modern technology, extreme precision, and human expertise. This is the complete journey, from raw metal to clean energy.
The hydroelectric turbine begins life inside one of the largest heavy engineering factories on Earth. High-strength steel is the foundation of every giant hydroelectric turbine. This special steel is designed to survive enormous pressure, vibration, and decades of operation.
To shape the turbine, raw metal must first be heated to extreme temperatures. Temperatures exceed 1,000 degrees Celsius. Powerful forging presses begin forming the core parts of the turbine. Each press strike improves strength and removes internal weaknesses.
Precision machining gives the turbine its exact shape. Even a tiny error could reduce efficiency or cause failure. Every hydroelectric turbine component is measured with laser accuracy.
The turbine shaft transfers water power into rotational motion. Perfect balance is critical for the giant hydroelectric turbine.
Automated welding ensures deep, flawless joints.
Every weld inside the turbine is inspected internally.
Smooth surfaces allow water to flow efficiently.
Even surface roughness affects the performance of the Giant hydroelectric turbine.
Each part is built separately before final assembly begins. Manufacturing a giant hydroelectric turbine takes months of non-stop work.
Engineers monitor every step using advanced digital models.
Now, the real assembly of the giant hydroelectric turbine begins.
Final assembly of the turbine begins inside a specialized heavy engineering hall. At the heart of the giant hydroelectric turbine is the runner.
Each blade is carefully shaped to guide water efficiently.
Blade alignment is critical for the giant hydroelectric turbine. Once aligned, the blades are permanently welded in place.
This shape converts flowing water into powerful rotation.
Even weld seams are smoothed for perfect water flow.
The main shaft connects the runner to the generator above. Microscopic alignment prevents vibration and energy loss. Bearings support enormous loads inside the giant hydroelectric turbine. Continuous oil flow reduces friction and heat.
The spiral casing directs water evenly toward the runner.
Balanced flow maximizes efficiency and power output.
Seals prevent leakage under extreme pressure.
Each bolt is tightened with controlled force.
The core of the giant hydroelectric turbine is now complete.
Guide vanes control how water enters the turbine. They adjust power output in real time. Modern control systems move the guide vanes precisely. Sensors monitor speed, pressure, and temperature. The giant hydroelectric turbine constantly adjusts itself.
Before leaving the factory, everything is inspected.
Hidden flaws are detected without damaging components.
This machine will soon be installed deep inside a dam.
But first, we must understand how water creates power. Everything begins with stored water high behind the dam. The deeper the water, the greater its potential energy. When released, water accelerates toward the hydroelectric turbine. Gravity transforms stored energy into motion. The spiral casing distributes water smoothly around the turbine. Guide vanes control both water speed and direction. Opening the vanes increases power output. Water pushes against precisely shaped blades. This force causes the runner to rotate. Rotation travels up the main shaft.
Water energy is now mechanical energy.
Efficient design reduces turbulence and energy loss.
The draft tube recovers remaining energy.
Small design changes create massive efficiency gains.
Bearings carry hundreds of tons of force. Lubrication keeps everything moving smoothly.
Temperature is constantly monitored.
Smart systems protect the giant hydroelectric turbine. This machine runs non-stop for decades. The water returns to nature, unchanged. After factory completion, the Giant Hydroelectric Turbine begins its journey to the dam.
Transporting the Giant Hydroelectric Turbine requires military-level planning.
Even transport vibrations are carefully controlled.
Each part arrives in a strict installation sequence.
Heavy cranes position parts with millimeter precision. The Giant Hydroelectric Turbine will be installed deep underground.
This chamber is designed to contain enormous forces.
Installation begins from the bottom up. Perfect vertical alignment is critical.
Even a tiny misalignment could cause failure.
The heart of the Giant Hydroelectric Turbine is now placed.
Clearances are measured to the millimeter.
The turbine is locked permanently into the dam structure.
Concrete absorbs vibration and reinforces strength. The dam and turbine become one solid system. Control systems are connected and tested. Every signal line is protected and redundant. Once sealed, access becomes extremely limited. The Giant Hydroelectric Turbine is now ready for operation.
But electricity has not yet been created.
Above the Giant Hydroelectric Turbine sits the generator. Rotation from the Giant Hydroelectric Turbine drives the generator rotor.
Powerful magnets spin inside coils of copper wire.
This motion pushes electrons, creating electric current. Slow mechanical motion becomes fast-moving electricity.
These coils produce enormous electrical power.
Electricity is generated as three-phase alternating current.
Speed control keeps power stable and safe. Water flow is adjusted to match demand. Electricity flows out of the generator.
Transformers increase voltage for long-distance transmission.
Higher voltage reduces energy loss. Power travels hundreds of miles. All powered by the Giant Hydroelectric Turbine.
This system operates continuously, day and night.
Before going live, every part of the Giant Hydroelectric Turbine undergoes rigorous testing. Gradual startup ensures no component is overstressed.
Sensors measure load, temperature, and vibration continuously.
After weeks of validation, the turbine is certified operational.
The Giant Hydroelectric Turbine now sends clean energy to millions of homes.
Entire communities are powered reliably and sustainably.
From homes to industries, life flows with this electricity.
And all this happens while water returns to nature unharmed. A perfect harmony of engineering, nature, and human ambition.
From raw metal to megawatts, this